Hey, good evening, guys. So, our topic for today is all about limits, and we're gonna talk about limits of a function, properties of limits, then limits of a quotient. So, let's go. Limits of a function. Limits of a function is a function f of x has the limit as x approaches a. The limit of a function is denoted by lim lim x is to infinity, where f x equals to limits. So the limit of a function x where x approaches to infinity is equal to L. So example lim x approaches to 10 and x over 2. So we just substitute the value of x to 10. So this becomes equals 10 over 2 is equal to 5. Therefore, lim x approaches to 10, x over 2 is equal to 5. So now for a second example, lim x approaches to 1. So x squared minus 1 over x minus 1. So we will factor it. So we will factor x squared minus 1 into x minus 1 and x plus 1. So we are factoring. So this becomes lim x approaches 1, x squared minus 1 over x minus 1. Now this is equal to lim x approaches to 1, x minus 1 and x plus 1 over x minus 1. So we will cancel out. So the remaining is lim x is to 1, x plus 1. Therefore, this becomes 1 plus 1 is equal to 2. Therefore, lim x approaches to 1, x squared minus 1 over x squared minus 1 is equal to 2. So, that's the limit of a function. Properties of a limit. So, the properties of a limit, it has limits of a constant in which the constant is equal to the constant. So, lim as x approaches to a is c equals to c. So, you just get the constant. Now, moving on to the limit of the sum, it is equal to the sum of their limits. So, you just get the sum. Yeah, so the difference of two functions use subtract, like f of x minus g of x. Then it's equal to f of x minus g of x. Then limits of the product is equal to the product of their limits. So you just multiply it to get the limit. And that's basically the properties of a limit. It's just addition, subtraction, and multiplication. And also the constant. Yeah, that's it. So the final part of our topic is limit of a quotient, which is the limit of a quotient is the quotient of two functions and their limits. Limit in the denominator is non-zero or not equal to 0, meaning as long as your denominator is not equal to 0, then it's okay. It's limit of a quotient if it's not equal to 0. So as for the example that I think will probably best help me explain limits of a quotient is that lim x approaches to 2, 4 over x plus 2 becomes 4 over 2 plus 2 because we just substituted the value of x for 2. So this becomes 4 divided by 4. So any number divided by itself equals to 1. And I guess as the quotient rule said, as long as the denominator is not equal to 0, I guess this counts. Yeah. So yeah, that's basically it. Yeah, so that's it for my topic on limits, the different properties of limits, the functions of a limit, and the limit of a quotient. And I hope that my explanation gave you at least an idea on how limits work and the properties of limits, how you can use them, like the basic examples that I use. And yeah, thanks for watching.